Welcome to Stats Video 4, the last one. This is on page 8 of your notes. You also most definitely need a calculator. So we are going to talk about bivariate statistics and correlation coefficients. And the word bi, like bicycle, two wheels, has to do with two. And so this is a comparison of two sets of data to look for what we call correlation, which leads to this word correlation coefficient, words I should say. And so correlation coefficient measures the strength and direction of a linear relationship. Okay, and correlation coefficient, we have an R is what is represented. So basically we could have strong positive correlation, so that would mean that the points almost form a straight line in with a positive slope. Or we could have strong negative correlation where we have a negative slope, almost a perfect straight line, or we could have no correlation, and then we can have these moderate, which would be in between. So if it's perfect positive correlation, so if it's perfect, as in all the points are on the same line, the R value would be equal to 1. If it's perfect negative correlation, the R value will be equal to -1. If it's perfect no correlation, the R value would be equal to 0. But in reality, usually we're sort of in between somewhere. So these points that are on your paper have an R value of approximately 0.9. The moderate correlation, these points would have an R value of approximately 0.5 to 0.9. If I come over here to moderate negative correlation, they would have an R value of approximately -0.5 to 0.9. And this one is in reality approximately -0.9. So we can tell something about what's going on with our data just by knowing our correlation coefficient. And so basically with the positive, it just means if the X value goes up, so does the Y value. In the opposite, in the negative situation, the X value goes up and the Y value goes down. Okay, so let's go ahead and play around with this a little bit on your calculator. So what you need to do if you want to practice this with me, and there's a lot of button pushing, you might want your template of your calculator out so you can write down some notes, is you want to go to your list and you want to put your data in, sorry I keep hitting the wrong buttons here, stat edit. And you'll notice that I've already put my data in list 1 and list 2. So if you want to follow along with me, you might want to stop the video and do that. So this data has to do with the math and the critical reading scores for the SAT for some schools in Ontario County. So one thing we often like to do is actually do what we call a stat plot. So once you get your data in there, and I'm going to do it and then I'll jot the notes down for you so you can have that, is you want to hit second y equals. And more than likely your plots are going to be off because it's really a good place to usually have your plots off. And by the way, if your plots are on and you want to turn them off, if you hit 4 and hit enter, that will turn your plots off. You'll find sometimes things aren't working with your calc. It's because your plots are on and it's getting in the way. So I'm going to come back in here again and I'm going to hit enter and I'm going to turn this plot on. Then I'm going to drop down here to the type and I want a scatter plot, so I'm going to hit enter to turn the scatter plot on. Now the way I've entered my data into my calculator, the values that I want to be my X values are in list 1 and the values that I want to be my Y values are in list 2. And you get a choice of what kind of marking you want. This first marking is kind of a little box, then this is a little X or plus sign, and then this is a little point, which I find really hard to see. So I'm going to just leave it on this little box. Now, when we're using our stat plot, the best window, so you don't have to find the window, you can get by hitting a zoom 9. So if you hit zoom 9, you will get a scatter plot to show what your data looks like. So hopefully, just from what we've talked about so far, you'll realize, oh, well, it's clear we have some positive correlation. At this point, we don't know exactly what the value is, but I'm going to go over back here again, and you'll notice it's that picture with this. There's going to be a line there. You're going to have that also in a minute. But I want to just go ahead and write down sort of what we just did, so you have that. So to do the scatter plot, what we did was we hit stat, we hit enter, which you should be used to doing this from previous sections and stats. We put our data, in this case, we put it into L1, L2, at least that's what I did. And we hit second y equals, and we turned our plot on. And then we told our calculator we want a scatter plot, so this was all on that screen, and we told it the x values are in L1, the y values are in L2, and then in order to get a nice window, we did a zoom 9. So these are all things that should become familiar to you. Okay, so then the next thing we'd like is that we would like to know what the correlation coefficient is, and we'd also like to know what the line of best fit is, or the regression line. So I'm going to go through that process and we'll jot a few notes before I go back to my calc. So we want to figure out what we call the regression line, also known as the line of best fit. Now, in the past, you may have just sort of eyeballed your line of best fit, put a ruler down, and as best you could draw it. But in reality, we can find out what the best fit line is. And what the calc is really doing is it's minimizing the squares of the vertical distance to each point. Now, it's not that important that you really know this. Once again, if you take stats, we'll play around with this a little bit more, but that's what causes this to be the line of best fit, because basically we found the best location to minimize this distance. So, in order to do that, I'll just write a few calc steps down and then I'll do it. We're going to hit stat, we're going to arrow to the right, we're going to hit 4 because we're talking about a linear regression, and we're going to hit enter. So I'm going to go ahead and I'm going to do that. So I'm going to go back to my main screen. I'm going to hit second mode. I'm going to go ahead and clear my screen, and I'm going to hit stat, I'm going to arrow to calc, and I'm going to hit number 4 for reg, it says, meaning linear regression. And now my calculator is bringing up the screen where I'm saying L1, L2. This frequency list here, I'm going to hit clear. Let's see here. You know, this is interesting. Store the regular equation. I'm just going to leave that for now, and I'm going to go down here to calc. If you have a TI-83 Plus, at this point, when it gets on your screen, you're going to just hit enter, and it will automatically use L1, L2 unless you tell it otherwise. So I'm going to go ahead and hit enter. And I get y equals, and there, you'll notice there's a y equals ax plus b. So the thing that you need to realize is that this thing a here is listed below. That would be your slope, and this b, your y-intercept, is listed below. You always do want to actually write this as an equation. So the equation is y equals 0.69x plus, if we round it to hundredths, plus 151.01. Let me come back here. I'm going to just write that down so we have that in your notes. So just to understand here, we get y equals ax plus b. A will be down below, and I think you've probably done this before, and A is your slope and B is your y-intercept. Okay, and so say I'm asked to give this, I'm going to just do it rounding to hundreds. I'll just write it up here so we can see it. So y equals 0.69x plus 151.01. Okay, now the other thing though that we usually want to know is what is the correlation coefficient? And so what we need to do, and some of your calcs may have already come up with an R on your screen, so you don't have to do what I'm about to do. But if your calc doesn't have an R on your screen, you need to follow the following directions. So what you need to do is you need to hit second 0 to go to your catalog. And you'll notice a little A up in your screen, which means you're in alphabet mode. So I'm going to actually go to D, which is for diagnostics, and I want to turn my diagnostics on. So since I'm in alphabet mode, I should be able to just hit that screen. And I'm going to go on down here to diagnostics on. And I'm going to hit enter, and I'm going to hit enter to make it happen. Now I'm going to run this again. So I'm going to hit stat calc 4 for linear regression, and I'm going to come on down here again and hit calculate. And you'll notice there's an R squared and an R, and the thing that I want is the R. And so in this case, that's what we call a linear correlation coefficient. It is 0.89. So I'm going to come back to my notes and I'm going to write that down. So in this case, R is equal to 0.89, which is moderately strong positive correlation. Probably could even call it strong. So basically you can talk about whether it's positive or negative correlation, and you can talk about, is it strong, is it moderate, you know, how closely correlated is it. Okay, now say you want to actually get that line to graph. So I'm going to come back here for a second and I'm going to show you how you can bring that into your y equals. By the way, you always want to make sure your y equals is clear before you do your scatter plot. So if you had some lines shooting through, you might, if you try it again, make sure you've cleared out your y. If I go to my y equals and after I've done my correlation, run my linear regression, hit stat, arrow, and actually, I take that back. I'm in my y equals and I'm going to hit vars 5, arrow, arrow, enter. It will actually bring the equation into my y equals, not rounded. So it's like the most accurate way to bring this over. And now if I hit zoom 9 again, it will actually graph that line for me, which is what you have on your paper. Okay, so let's go on down here and do another one. Create a scatter plot on your calc of the data below, tracks a person's weight by month, find the regression line correlation coefficient, graph the regression line on your calc and sketch it below. Comment on the strength of the linear relationship. So if you want to do this, you might want to stop the video, input the data. I've already got it in my calculator, and this will give me an opportunity to show you how to use different lists. So I'm going to come over here, I'm going to go ahead, I'm going to hit my y equals and clear this thing out that I used before. I'm going to hit stat, enter, and I just want to show you for the purpose of saving some time here, I have put this data in list 3 and list 4. So I'm going to go ahead, I'm going to hit stat, calc 4 for linear regression, and I need to tell my calculator that my data, the x values are in L3 and the y values are in L4. Now if you have a TI-83 Plus, then what you would do is on your main screen, after you hit enter, you type in L3, L4. And I'm going to come on down here and I'm going to hit calculate. Okay, so I have my linear regression, my correlation coefficient, as well as my equation on my screen right here. If I want to graph this, I'm going to hit my y equals. I'm going to hit vars 5, arrow, arrow, enter. And I'm going to hit zoom 9. And why is my line not graphing? Actually, I know why. Okay, this is yet another good thing to show you. So I'm going to go to my stat plot, and I'm going to go to my plot on, and I need to also, in this location, tell my calculator that I'm graphing the stat plot that is L3, L4. So now if I do zoom 9, I should get the correct Let me get out of this. I'm going to do zoom 9 and hopefully I'm going to get what I'm looking for. Okay, because in this case, and this is what you would want to sketch if you want to try to sketch this onto your paper. Just a couple other things while I'm thinking of it. You'll notice you have different plots. So another option is if I wanted to keep plot 1 as it was, I could have gone down here to plot 2 and done my L3, L4. So there's a lot of, your calc has a lot of power to not have to keep eliminating data. Like if you want to save some data, not have to type it all back in again. Okay, so in any case then, this turned out to be y equals negative 6.28x plus 254.59 with an R value. In this case, I'm going to round it to negative 0.998. And I would say this definitely has strong negative linear correlation. Now, as an extension, you may be asked to actually use your model. So use your model, and this being your model. So use your model to determine the weight of this person at month 5, at 5.5 months. To find weight at 5.5 months. And so once you have your equation into your y equals, which I do right now, I now have the ability to go to my table. So I'm going to hit my second and go to, this is my table. Now remember, your lists are different than your table. Now I'm going to go ahead and put my calculator into ask mode, and I'm just going to ask my calc, hey, tell me using the line that I've just created, the model, how much this person weighs at 5.5 months, and I get approximately 220 pounds. So this is how we would actually use our model to figure something out. Okay, and that should make some sense, hopefully. Remember, if you look here at about 5.5, but remember, this is the model. It wasn't a perfect model. It was very close when I looked here. Okay, one last problem. Once again, if you want to follow along with me, maybe turn off the video, put the data in. Determine if the data below, showing the months versus the average high temp in Albany, can be represented by a regression line. So I'm going to come back over here to my calculator. I am going to hit Stat and Edit. And in this case, I'm going to continue to use my list 3 because that's where my numbers 1 through 12 are, but this data I have actually in my list 5. I'm going to hit my y equals and hit clear. And now I'm going to go to my stat plot. Now, this is where I have to keep my head straight about where I've put my data. So my x values are still on list 3 and my y values are now in list 5. I'm going to go ahead, I'm going to hit zoom 9. I don't know why my calculator is doing this. I'm going to hit zoom 9. And if you look at that, that is not something that we want to use a regression line for. So the answer to this problem is going to be no. But let's go ahead and just figure out what the linear correlation coefficient is just for kicks. So I'm going to hit 4, hit enter. Down here actually hit calculate. And you'll notice, okay, hold on a minute. I apologize for that. Stat, calc, I'm going to hit 4. The reason that didn't come out as I expected is because I need to change this to list 5. Come down here and hit calculate. And you'll notice that my R value is very low. It is 0.29, which clearly this data does not want to be modeled with a line. Now, this is not so much what we're doing right now, but I just want to show you something. When I look, I'll come back here and look at this stat, my plot again, my scatter plot. When you hit stat and you go over here to calc, you'll notice that besides a linear regression, there's other things like a quadratic regression, for instance. So I'm going to go ahead, I'm going to hit enter, and I am going to let my calculator do a quadratic regression. And I'm going to hit my y equals, and I'm going to hit bars, 5, arrow, arrow, enter, and just show you how there's different models that can be used. So if I hit zoom 9, you'll notice that this now instead has a quadratic trying to model this data. And so there's others also. If I hit my stat and I go over here to calc, there's a cubic regression, and we could play around with any of these. In reality, believe it or not, if I scroll all the way down here, it's the sign regression that actually is probably the best fit. We don't need to be concerned about that now, but be aware, and this is what people in the real world do when they have data and they're trying to figure out the best model for their data. Be aware that there's all different types of models. Sometimes we use linear, sometimes we use quadratic, cubic, whatever. So, there you have it. Go on over to Math Excel for Schools and do stats practice number 4.